Hello everyone. So before we start Calculus 2, I would like to kind of have a review from what you learn, and especially the topics that we need for Calculus 2. So I'm not going to go over like everything, but I'm going to focus on the topics that's important for us. Okay. So I'm going to call it review Calculus 1 review. Calculus 1 review. So we're going to focus on two things, especially first we're going to do the limits and derivatives in one section, and then I'm going to have a separate section for antiderivatives, because the rest of the Calculus 2 is basically depend on antiderivatives. Okay, so let's do the first one, the limits. So remember, this is not everything, but this is like just major topics, because we cannot take too much time, but I still would like to take some time to kind of like make sure that we know pretty much what we need to know in this class. Okay, so the limit. So what's the first idea? Sometimes what happens, so what's the limit actually? So let's try to have an idea from a graph. So let's look at these two situations. So let's say you have like a nice graph, what we normally call a continuous function. So continuous means we just like CTS, that means continuous function. So what's the limit is, like let's say the limit as this limit at a. So limit at a means what you're trying to do, you try to, so I'm going to call this is x, I'm going to call this is y. So you can use pretty much any letters, but let's use x and y for the moment just to make it easy. So what we're trying to do, you try to go to a from both sides. You got to go from the right side and the left side. When you try to move, what will happen, you move along the graph this way and that way, and you can see that when the x value changes to get closer and closer to a, you can see the function value closer and closer to this value. So that means what you can say, the trend when x reaches a, so the trend or the limit, that's called the trend. So we are looking for the trend. The trend is the limit. Okay, so we call that trend limit. So what happened when x reach a from both sides? So if I call this function is y, or you can just say fx if you want. So what's going to happen? So whatever the value here, is that right? Whatever the value here. So if I say that value is L, so I'm going to call the value is L, whatever the value is L. So if that value is L, then the limit is L. Okay, so that's what happens. So when x goes to a, the function reaches the value L. So that means if you have a continuous function, this is easy. This is simply you evaluate the function at a. So right, you have a function, you can evaluate the function at a. So you can do that if the function is continuous, no problem. Okay, now what's happen if you have a function like this? So let's look at the other case. So let's say you have a function, it's going to go like that until a from one side, and then it's going to have a jump, and then you have another value like that. So what happened here now? So we have a y and x. So what's going to happen here, when you're coming from one side, left side, you're going to reach that value. Let's say that value is L1. When you come to the right side, you are reaching along this path. So that means you're going to reach the value L2. Now the problem is which one you are going to pick. So for example, if you can write this one as, in this case, limit when x goes to a from left, that's why I put a minus sign, fx is not equal to the limit when x goes to a from right. So you can see these two values are different. It is L1 and L2. They are not the same. So that means in this case we say the limit when x goes to a of fx does not exist. So right, the limit does not exist. So there's no limit in this case. So that means you cannot find the limit by plugging. So right, if you plug in the value, you don't get it. So plug in x equal a to fx does not work anymore. So right, that doesn't work. So this is not a trick anymore. So because the function is not continuous, so there's no way you can find the limit that way. So this is the kind of major idea, right? This is the kind of major idea, but still you can find the left limit and the right limit. There is a left limit, that is L1. There's a right limit, that is L2, but unfortunately they are not equal. Okay, so that's the situation, and in this case we say the limit doesn't exist. So that means you kind of get an idea, like, what happened, if you have a function which is continuous, no problem, just plug in the value, you get the function value, you get the limit. If the function is not continuous, you have to be careful because the limit does not exist. Okay, but still there is one more situation. Let's look at this one, the third case. So there are a lot of cases, but this is like another case. So what if like you have a function like that and at a, and then you have the rest of the part going like that. So it's like pretty much the first one, but there's a hole in there. So that's a, and then the a at a you have a function on the value. So let's say that's your L1 as before. So in this case that's L1, L as before. That's the same L from this one, and this is K. I'm gonna say K or something. So what happened now? So you can see that in this case, when the limit x goes to a from the left side, from the smaller values, what will happen? If you go from left, function reach L. So right, reach L. Also, if you coming from right, what will happen? If you come from right, you can see still the function goes to the same value. So that's an interesting situation, right? You're gonna see the function reaches the same value. So what happened in this case? The two values are the same. You see, it's the same. It's not a smiley face. It's the same, but actually that's a smiley face situation, because you see that the two values are the same. So the limit exists. The trend, there is a trend. What's the trend? They try to reach the value. So there is a trend. There is a trend. What's the trend? Trend is L. It's try to reach the value L. So that value is what we call the limit. So in this case, the limit is actually L. It exists and it equals to L. It's equals to L. So you need to understand these three cases, because any limit situation you can bring into one of those cases. Any limit situation you can bring into one of those cases, even when you have infinite limits. When you have infinite limit, what will happen? Maybe one side you have a value, but the other side there's no value, is going to go to infinity. That means there's no limit situation, right? Limit does not exist situation. So you have to be careful in this kind of situations. But just remember these three situations. So I'm going to call this is slide number 1. So this kind of combine all major situations into one. Okay, now let's try to look at what's going to happen in algebra. So what you learn in your classes. So let's say let's look at some algebraic situations. Okay, so some examples. So I'm going to go like little quickly because we don't have too much time. So so let's say find the limit. Let's say x goes to -1 for x cubed minus 7 x, let's say 7x squared, 7x squared, and then plus 3. How about square root? Something like that. Okay, so so you can see this is what you have inside is a polynomial, but we know that the polynomial functions are always continuous, and then you have a square root function. A square root function is also continuous on its proper domain if it is not a complex number, because you try to take a square root, that means the number has to be positive inside. So let's see whether that's a situation. So you can see this is like nice polynomial. Let's plug in the value. Okay, so once you plug in the value, so what's gonna happen? So so you can see that so what do you get? you're gonna get 4, -1 cube, -7, and then -1 square plus 3. Okay, I'm gonna put like a question mark because we still don't know. So and then square root. So what's gonna happen? 4, -1 cube is -1, and then here -7, -1 square means 1 plus 3. So what do you get? What do you get? You can see that this is -4, -7 plus 3. Right? So how much you get? You get -8 square root. Is this a kind of real number? Not really. So in that situation, we actually don't know whether the limit exists as a real number. So this is kind of confusing because we don't know. So so this will be better to put this as a limit does not exist situation, because this is not a real number. It's like a complex number. So we can kind of skip this kind of situation. So let's try to kind of slightly change the value. So how about this one? Okay, so I want to tell you like where you get stuck. Okay, so you can see like you can just plug in, but not always. So how about this one, -1? I'm going to slightly change the problem. So and then so what I can do is so I can say plus instead of minus I put a plus sign, so x squared plus 3. So you can see that I slightly change a number, just one number. Okay, so now let's see what's gonna happen now. So again, so we're gonna plug in the value. So we're gonna see cube plus 7, -1 squared plus 3 square root. So you're gonna get 4, -1 cube is -1 as before, plus 7, -1 square means 1 plus 3, and then what's gonna happen now? So you can get -4 plus 7 plus 3. So how much you get? How much you get? So you're gonna get 6, right? So it says 6. So here you get 6 is square root 6, and that is the answer, because that's a nice real number. So the limit is square root 6. See the difference between the two, because what will happen, you feel like you can just plug in the value, but not really. So here in the first example that didn't really work, because when you try to do that you get a complex number, but we don't consider those as like real. We don't consider this like a limit exist situation, so it's not. Okay, so let's look at more examples. How about this one? So please try to understand the difference between the two. Okay, so how about this example? So let's say limit x goes to how about 2, and then x squared minus x minus 2, and then x squared minus 4x plus 4. So so what we're trying to do, you're going to see whether you get any zeros in the bottom. Actually you can see that unfortunately you get a 0 in the bottom, right? You get a 0 in the bottom. So so what we can do here, so you can see is the limit x goes to 2. What are the factors here? X minus 2, x plus 2 divided by x minus 2, x minus 2. And then what's going to happen now? You can see that this term get cancelled. So and then you're going to get limit x goes to 2, you're going to get x plus 1 over x minus 2. Okay, so what's going to happen now? So can someone tell me what's the answer here? So what this looks like. So you can see, so this is a situation like you need to look at what's going to happen separately, but you can see that when x goes to 2, the top part getting closer to 2 plus 1, that means 3, right? So they're going to stay around 3. It doesn't go too far away from that. You're going to stay around 3. the numerator. What about the denominator? The denominator have a very drastic change here. What is if you just pick the denominator part, what it looks like? So I'm going to draw a graph here. So what's going to happen? That's the 2, number 2. So you can see that when x getting closer and closer to 2, the bottom part getting closer and closer to 0. That's very clear. If x getting closer and closer to 2, the x minus 2 getting closer and closer to 0. So that means you try to divide. So this looks like 1 over x minus 2 situation. Right? 1 over x minus 2. So that's the kind of number you have. The numerator is stuck with 3. So it doesn't change much. Stay with 3. But the bottom getting closer and closer to 0. That's when you divide 1 over a very small number, you know that it's going to go to infinity. But the problem is, when we divide by a very small positive number, it's going to go to positive infinity. When you divide by a very small negative number, it goes to negative infinity. So that means in these two situations, if x is coming from right, you can see that the denominators are getting closer and closer to 0, but through positive value. That means it's going to go to positive infinity. Right? It's going to go to positive infinity when you're coming from the right side. When you come to the left side, still going to go closer to 0, but those are very, very small negative value. That means it's going to go to negative infinity. So that's the situation. When you come from the left side, it goes to negative infinity. When you come from the right side, it's going to go to positive infinity. So that means at x equal 2, limit does not exist, because it's going to go to two different ends. It's going to go to two different ends. So that means, so what will happen in this situation? You cannot pick anything, because even though the numerator go closer to 3, but the bottom goes to one side goes to positive infinity, other side goes to negative infinity. So that means this is a limit does not exist situation. Okay, so think, how many of you get the answer right? Okay, so if once I give an example like that, so the best thing would be write the problem and see whether you can solve it. Okay, so if you can solve it and get the answer, you are good. Okay, if not, you can learn it right now. Okay, it's not that difficult. So, but if I just ask you what is the left limit or right limit, then you can answer the question. So for example, I'm going to slightly change the problem now. So if I say, I'm going to use a different color for that. So let's say limit x goes to 2 minus x squared minus x minus 2, x squared minus 4x plus 4. You can see it's the same work, but now the top is 3, the bottom goes to 0, but through negative values. So that means your answer become negative infinity. Okay, so you can see it's a negative infinity. I mean, you can see it does not exist, but the negative infinity is much better, because it's kind of tell you what's really going to happen. Okay, you say equal to infinity. Okay, so yeah, so let's look at one more example. How about I'm going to change the problem to this. So I'm not going to change much. I'm going to slightly change the problem to this one. So the next example is limit x goes to 1. So you can say x squared minus x minus 2, x squared minus 4x plus 4. So it's pretty much the same, but I change the value of x. So we do the similar work here. So you can see that in this case, when you plug in the value 1, it doesn't change anything. So right? I'm sorry, when you plug in the value 1 to the top and bottom, you do not get a 0 in the denominator. So if you do not get a 0 in the denominator, you can plug in the value. So that means for the limit, so you don't want to write this one now, you can just plug in the value, because when you plug in the value to the denominator, you do not get a 0 here. So let's plug in the value now. So it's a 1 squared minus 1 minus 2 over 1 squared, and then minus 4 times 1 plus 4. So how much you get? you're gonna get negative 2 over 1, that means negative 2. So that's the answer. So when there are some problems, you can just plug in the value and get the answer, because you do not get a 0 in the denominator. So if you get a 0 in the denominator, you have to be careful to make sure that it's going to give you something useful. Okay, so let's do one more example just to make sure that it is clear. So so let's do this problem. X goes to 2, so we have x squared minus x minus 2 over how about this one, x squared minus 2x, yeah, something like that. And you can see that when you plug in the value 2, you get the 0 in the top, 0 in the bottom. But if you get a 0 in the top and 0 in the bottom, that's a kind of good situation, because you can use some kind of algebra to simplify this. Okay, so if you get 0 over 0, you have a way to do it. Okay, so let's see how we can do it. But you remember what we did, so we're gonna kind of factor it. So we're gonna factor, so you're gonna x minus 2, x plus 1, and then we have x, then we have x minus 2, right? Now what we're gonna do, we're gonna simplify. You can see that this get cancelled, so you're gonna get the limit x goes to 2, x plus 1 over x, right? And then now what we can do is, you can see that you can plug in the value to get the answer right now. So we're gonna get 2 plus 1 over 2, so you get 3 halves. Okay, so that's the answer. So let's do maybe one more. How about this one? So I'm going to give you like several different examples before we move on to the other ones. I would like to do this one. Limit x goes to 1, 1 minus square root x over 1 minus x. Okay, anyone want to try it? Limit x goes to 1, 1 minus square root x or 1 minus x. How we can do it? We can factor, right? We can factor the bottom. So what are the factors? Limit x goes to 1, 1 minus square root x. We can write 1 minus square root x, 1 plus square root x. Once you do that, now you can see you can cancel this term. You can cancel this with that, and then you're gonna get the limit x goes to 1, 1 over 1 plus square root x. So once you plug in the square root x, this becomes 1, so you get 1 half. So answer is 1 half. So not that bad. So if you have any questions, you can just email me, then I can reply, or you can just come to my office hours. Okay, so how about this one? Let's do a different example. X goes to 0. How about 1 over 2 plus x minus 1 half divided by x. So if you feel like you want to try this, the best thing would be you can stop the video and then you can try it and you can come back and see. So that may be the best way to learn mathematics, okay? Because in just watching, no one can learn. You need to do it. Okay, so any ideas what we can do? This division problem. When you have a division problem, you can turn this into a multiplication problem. Alright, so it's a limit. X goes to 0. I'm going to write this one as 2 plus x minus 1 half. I'm going to make this division problem to a multiplication problem. How? Division is 1 over x, right? So you can write it like that. So that's the first thing to do. You turn the division problem to a multiplication problem. Because you can see that you cannot just plug in the value. If you just plug in the value 0 to the top and bottom, you get a 0 over 0. So this is also a 0 over 0 situation. So 0 over 0 means you have to do something. Okay, you have to do something. You have to simplify. that's the 0 over 0, even the top one, so 0 over 0 situation. Then we have to do something. Okay, so let's do that. So what we can do, I'm going to take the common denominator here. So limit x goes to 0, so the common denominator is 2, x plus 2, so 2 minus 2 plus x, and then 1 over x. So just take the common denominator. Okay, so you guys are masters in this now, okay, because you did Calc 1, so you can discuss this technique a lot in Calc 1, how to simplify a fraction. Okay, now you can see the 2 and 2 get cancelled, this 2 and that 2 get cancelled, so you simply get limit x goes to 0, you get negative x over 2 x plus 2 1 over x, and now you can see that this x and that x get cancelled, so you get limit x goes to 0 negative 1 over 2 x plus 2, and at this situation you can see that you don't get 0 or 0 anymore. Okay, you don't get 0 or 0 anymore. If you get 0 or 0, you have to do something, you have to simplify. But if you do not get 0 or 0, then what you can do, you can plug in the values. Most of the situation, but not always. Okay, so if you plug in the value 0 now, so you're gonna get negative 1/4. So that's the answer, negative 1/4. Is that clear? Okay, I think it's clear now. So let's do more. How about a problem like this one? So another example. Limit x goes to 0, 2 plus x cube minus 8 over x, and you can see that in this problem also, when you plug in 0, you get 0 in the top, 0 in the bottom, so it's also a 0 0 problem. That means that's not the answer, you have to simplify. So right, you have to simplify. But yeah, so there are two ways to do this. One way is like, you can simplify and then you're gonna plug in the value, but I'm gonna, so that's one way to do it. You simplify, you're gonna do 2 plus x cube expansion, and then simplify the top, and then divide by x, and then plug in. Rather than that, I'm gonna do the L'Hopital's rule. Remember, when you have a 0 over 0 situation, you can use the L'Hopital's rule. What's the L'Hopital's rule? Take the derivative first and then plug in the value. So let's do that. So I'm gonna go for the L'Hopital's rule. So I'm gonna say LH rule. Okay, LH rule, L'Hopital's rule. So what's the L'Hopital's rule? It's the same limit. What we do, we can take the, it's only, so it works when you have 0 over 0 or infinity over infinity. Okay, it doesn't work for any other cases. All the other cases you have to bring it to one of those forms. So again, so the L'Hopital's rule works when you have 0 over 0 or infinity over infinity. Those are the only cases the L'Hopital's rule works. So what the L'Hopital's rule says? Instead of the function, you can replace the functions by its derivatives. Right? It only works for these two situations: 0 over 0, infinity, infinity. Everything else you need to bring it to one of those forms. It doesn't matter which form, just bring to one of them. Okay, so that means we can take the derivatives. So what's the derivative? How to take the derivative at the top? You have to use the chain rule. So if you use the chain rule, what do you get? You're gonna get 3, 2 plus x squared, and the derivative of inside is 1. So you don't want to write it. That's for the top, and then minus 0 because 8 is a constant, and from the bottom you get 1. So that means if you simplify this a little bit, you're gonna get limit x goes to 0. So we have 2 plus x. This is a really nice function, so you can plug in the value 0 here. So that means 3, 2 squared, you're gonna get 12. So the answer is 12. Okay, so it's not that difficult, so you can do it using the L'Hopital's rule. So so I'm gonna also ask you to do it using algebra. Okay, so why don't you try it using algebra? So as algebra, you can expand 2 plus x first. Okay, 2 plus x to the cube. You expand it and then simplify. Okay, so use the algebraic method. Okay, so algebraic method. Try it and see whether you get the same answer. I'm gonna leave you some space for that. Okay, good. So let's continue. So how about a problem like this? Do you remember this result? So I'm gonna write the result first. So we had a okay. Before that, I would like to write the L'Hopital's rule. I would like to write the L'Hopital's rule. So what's the L'Hopital's rule? So what's the L'Hopital's rule? L'Hopital's rule says the limit when x goes to a, fx over gx is exactly equal to the limit x goes to a f prime x over g prime x. This doesn't work always. If the f a equal g a. So once you plug in the values, you should get those two are equal. Okay, equal to, not just equal to 0. Okay, so you should get when you plug in a to the two functions, you should get 0 in the top and bottom. Okay, so that's the requirement. Under the requirement, you can do that. Okay, so what should happen when you plug in the value? The top and the bottom should be 0. The top and bottom should be 0. If the top and bottom are 0, then you can use the derivatives. Okay. Good. So that's the L'Hopital's rule. And then also we have another result. So what's the other result is? I'm going to put a star here. The limit x goes to 0 sine x over x, which is equals to 1. And it also works even if you turn it backward. So it's a limit x goes to 0 x over sine x. This is also 1. Okay, so that is another result. These are useful, sine x over x is equal to 1, and you can use them. And it's very easy to prove using L'Hopital's rule, because if you take the L'Hopital's rule, you can see when you plug in x equals 0, both goes to 0. The top is 0, bottom is 0. So you can use the derivatives. So once you use the derivatives, what will happen? It's the limit. Take the derivatives. So once you take the derivatives, get 1. Derivative of sine is cosine x. Now once you plug in the 0, you get 1 over 1, which is 1. So yeah, so using the L'Hopital's rule, you can prove that. Okay, so we use the L'Hopital's rule to show that that's the case. Okay, so let's try to use that idea to do one problem probably. So how about this one? So I would like to do limit. This is another example. Limit x goes to 0. We can say tan 2x divided by sine pi x. Tan 2x divided by sine pi x. And you can see that both functions at 0 have the value 0. Right? The both function have, so it's a 0 over 0 situation. See that? When you plug in 0, the top function is 0 and the bottom function is also 0. That means you can use the either L'Hopital's rule, but L'Hopital's rule can make it like complicated at the beginning, especially because when you take the tan, it gets secant. What's the derivative of tan? Secant squared. And also you have to use the chain rule here because of the 2. So let's try to avoid that, see whether there's another way to do it. So what I'm trying to do, I'm going to use the result we just mentioned. So I'm going to do limit. I'm going to separate. So we did this problem in Calc 1. Okay, this is one of the example. We did not the exact same problem, but these kind of problems are very common in Calc 1. Okay, we do that. So you should have done this problem in Calc 1. At least couple of examples. Maybe you find this in the final exam as well. Just few days ago. Okay, so what we're trying to do, we're gonna split this. So tan is what? Tan is sine over cosine. That's a tan. So rewrite tan as sine cosine. And then the sine one I'm going to write separately, sine pi x. Okay, so that's the first thing. Now what I'm going to do, I'm going to rearrange the terms. I'm going to rearrange the terms so that we can use this idea sine x of x. So when you do sine x of x, it doesn't really matter whether x or 2x. Only thing is it has to be the same. It has to be the same. So that means if you look at these two problems, you can see in one you have 2x, in the other one you have pi x. So what you can do, you can treat them separately. So this is my idea. What I'm going to do, I'm going to rewrite them. So I'm going to do limit x goes to 0. So I'm going to do sine 2x. So what I will do, I'm going to divide this one by 2x. I'm going to multiply this one by 2x. So divide and multiply. So that's okay, because they can cancel each other. So we introduce that. And then I'm going to write the cosine term separately. Do a similar trick here. What I do? So I have sine pi x here. So what I do? I write pi x, multiply by pi x, divide by pi x. Perfect. So you have to do this rearrangement. And once you do this rearrangement, now you can see the first one, sine 2x divided by 2x. So sine 2x divided by 2x means when at the limit when x goes to 0, this thing gonna go to 1 because of the previous result. Only thing is that you need to match the two. They match, it goes to 1. The same thing here, when x goes to 0, see the pi x, that means this term also goes to 1. Goes to 1. What happened when x goes to 0 to cosine 2x? What's the graph of cosine? So the cosine looks like that, is that right? That's the cosine graph. So that means at 0, it is 1. So that means this one also goes to 1 at x equals 0. Now what we're going to do, for the other one, you can cancel this x. You're going to cancel this x, cancel that x. So you're going to get 2 over pi. So the answer is 2 over pi. 2 over pi. But that's the algebra. And you can see the shortcut is, see, 2 over pi here. But that's like just to verify that you get the right answer, but don't take that as the answer, because you don't get points if you just try to do that, because that's not how the mesh calculation works. You know, you to show what's really going on here. Either way, you can just use the algebraic technique like this. You can look at the expansion, break it into sine, cosine and do it, or you can use the L'Hopital's rule, but that can be complicated. I mean, not too, but too much. You just need one step, and then you can see that you get the answer here. Yeah, so why don't you try it? You know, use the L'Hopital's rule. See, I'm going to give it as an example. Probably I can ask one of these questions in the quiz Wednesday. So we have quiz every day. That means whatever we discuss today, it will be in the quiz Wednesday. Okay, so make sure that you go over this and try to do those questions that I kind of skip. I mean, it may be skip over what I just did. You know, I can probably ask the exact same question that we discussed. But what I want you to do is like just go over them and make sure that you understand them. Yeah, but I'm going to give you this as an example, as a problem. So what's the problem? I'm going to write in black. So I'm going to call it exercise. So it's exercise, the limit. So let's say limit x goes to 0, tan 2x over sine pi x. Use the L'Hopital's rule. Okay. So use LH, L'Hopital's rule. Okay. Use the L'Hopital's rule and see whether you get the same answer. It should be the same answer. It doesn't matter what method you use. Okay, so about that, let's do just one more example from this type. So the last one, limit, and then I'm going to go to one or two infinite limits, and pretty much that's enough for limits. You know, there are a lot of other things, I know, but we don't have too much time. So how about this problem? X goes to 0, 8x over 3 sine x minus x. Do you want to think about it a little bit? Any idea how we can do this? If I were you, I probably divide the top and bottom by x. Okay. So just to bring you see that x there. So I'm going to divide the top and bottom by x. So that's what I do. Okay. So the limit x goes to 0, divide by x, so you get 8. In the bottom you have 3 sine x of x and minus 1 and divide by x. Okay, now you take the limit. We know that the you can move the limit here, so I'm going to say 8. You can move the limit inside, so it's a limit x goes to 0 sine x of x minus 1. This is a constant, so there's no point putting the limit there. I mean, you can, but it's just 1. So I'm going to do it. But you know that after you do that, this side is simply equals to 1. So that means you're going to get 8 over 3 times 1 minus 1. That means 8 divided by 2. That means 4. So the answer is 4. Okay. It looks like you just subtract 8, 3, 3, 1, but it's not. So you can see how it works. So that's the answer. Okay. Yeah, I think this we did a lot of examples from this one, but I want to do like a limit at infinity. Limit at infinity. Limit at infinity. So how about a problem like this? So find the limit x goes to negative infinity 2x squared plus 3 over 5x squared minus 7. What we do in this case, you can see that when x goes to negative infinity, the top and bottom goes to infinity. So when they goes to infinity, what you can do is one method is you can use the L'Hopital's rule. That's one way to do it, because infinity problem. Or just divide by the largest term, largest power in the denominator. The largest power in the denominator is x squared term, so I'm going to divide everything by x squared. So that's what we do. So if you do that, limit x goes to negative infinity, so you divide by x squared, means 2 plus 3 over x squared, and then 5 minus 7 over x squared. That's what you get. But we know that when x goes to infinity or negative infinity, you know that the terms like this goes to 0. So those two goes to 0. So that means you end up getting 2 plus 0, 5 minus 0. So that means you're gonna get 2 over 5. And make sure you simplify this one. But 2 over 5 you can simplify. So it's a 2/5 is the answer. I probably do maybe just one more example. Yeah, so let's do this one. So that's another example. That's the last one. Limit x goes to positive infinity. Yeah, positive infinity. You have x squared minus 4x plus 8 over 3x squared. 3x cube maybe. How about cube? 3x cube. Yeah, so as before, what we do, we can divide by the largest power in the denominator. So like x cube. So if you divide by x cube, what do you get? You're gonna get limit x goes to infinity. You divide by x cube. So if you divide by x cube, you get 1 over x minus 4 over x squared plus 8 over x cube over 3, and you can see that when x goes to 0, x goes to infinity, the numerators, all the numerators goes to 0. This is a 0 over 3 situation. 0 over 3 means, don't leave this is not an answer. This is an answer, but it's not a final answer. Final answer is 0. Okay, 0. So yeah, so let's just go over these examples. So these are something about limits. Okay, so limits, and then so you can start the homework. In the homework I asked like similar questions there. So start today, you don't have much time. The homework is due Wednesday before the class start. Okay, so homework is due the next day before the class start, and then it's gonna clock at that point. So there, so you, and yeah, so so you don't get much time. So that's the summer, always go like that. So whenever you study the same day and try to do the homework as soon as possible. Okay, that's the kind of idea. Okay, so so that's the end of limits. Okay, so end of limits, and in the next one we trying to do derivatives. Okay, we trying to do derivatives.